Hello everyone. Uh, because I understood that session 6 was having some gaps, so these are small videos which would lead you till the understanding of session 6, and I would also release a video of session 6 again with minute details. Okay, these are some basic concepts or the building blocks. Okay, so let me start with the first important thing, which is called as probability. Okay, now what is the need of probability as such? In session 5, we read about mean, median, mode. We read about other statistics which would explain variance, uh, standard deviation, etc. Now, those were derived out of population, okay, which is why we call them population parameters, right? Something called as population is called population because it is done in a very large scale or has a very huge capacity or is very large in number in terms of experiments. For example, if we want to see the average weight of people living in India, and if we could measure the average of all the people's weight all around India, then it would be a parameter or a population parameter because it is a very large data set. Okay, but in real life, what happens? Human being, because it is only humanly possible to gather so much data. So we gather only a part of it, which we call as sample. Okay. Now, as the parameter that was discussed in the previous example, where we wanted mean of the whole population of India. Similarly, for the sample also, we will have a mean. Okay. Now, this sample mean is called a statistic, right? So, what is the whole process of finding out sample and what is the meaning of finding out statistic? The meaning is we from the population we derive a sample. From a sample we find a statistics, and from a statistic we make an assumption that how much is this statistic representative of this parameter. Okay, so we make an assumption that how close is this statistic to this parameter, right? And the more closer it is, or we if we can find more better ways to find the parameter in a way that statistics become closer to parameter, we would feel ourselves successful. Okay, so mind this main word, making assumption. Now, making assumption, which also means you are saying that statistic is representative of population with certain probability. Let's go to the previous example. We had to find out the average weight of the whole of India. We took only a sample, which is 2 crore people. We found the mean of it, and we will see how close can we bring the statistic to the original parameter. And how will we do that? For that, we will use various techniques of probability. And similarly, because machine learning or deep learning or this whole field is about increasing your skill set on making smart assumptions and making smart guesses so that you can accurately measure the original value. Probability becomes a part and parcel. That being said, let's start with some of the basic concepts of probability. Okay, let's talk about something called as classical probability. Okay, so classical probability is represented by probability of an event which is given by NE by N, or NE is the number of times the event E occurs, and N is the total population, right? This is the basic fundamental of probability. Okay, this probability lies in the range of 1 and 0, right? Now, all the probability problems and concepts that we will look at, will look through this window itself so that it becomes easier for us to understand. Okay, now let's define uh, the second most important part of probability, which is structure of probability. Now, what is the structure? Structure means the basic building blocks of a probability, or the terminology or the language in which probability speaks. Okay, one part being experiment. Now, what is experiment? It is the process that produces outcomes. For example, finding out who will win the toss, who will win the match, testing new COVID vaccine. Okay, there is another concept called as event. Now, what is event? It is the outcome of the experiment. Experiment, outcome. As you know, experiment produces outcomes. Outcome of experiment is event. Like, if this is an experiment, which is who will win the toss, the event will be getting head, or who will win the match, scoring high, testing corona vaccine, killing corona, right? Similarly, one more concept called elementary events. What does it mean? If rolling a dice is an event, getting one is elementary, which means you can't break it down to further subsegment. Okay. One more important part, sample space. What is sample space? It is the complete roster or listing of all elementary elements, events, listing an exhaustive list of all elementary events is sample space, right? I guess you all already know all these concepts, okay? But if we just remember these becomes quite refreshed so that we can proceed with our next concepts, okay? Now moving ahead, taking you to the concepts of unions and intersections, okay? If there are two sets A and B, the union of it will be all of it. If there are two sets A and B, the intersection of it will be only this part, right? Now you have mathematical functions to represent it. Okay, A union B, that is how you represent union. A intersection B is how you represent intersection. Okay, now let me take you to the concepts of mutually exclusive events. Okay, now what do mutually exclusive events mean? It means if two events which do not simultaneously occur and have no intersection, not simultaneous, no intersection. Okay, let me give an example. Suppose we are looking for a left handed batsman, right? In that case, being left handed batsman is mutually exclusive of being right handed batsman. They both can't simultaneously occur and they have no intersection. Left handed, right handed equal to 0, which means one person cannot be both left handed or right handed while he's playing a game. Oh, no, maybe a bad example. Let's take the example of a defective bulb. So a bulb can be either defective or not defective. Okay, they are not simultaneous. They cannot occur at a time. A bulb cannot be defective and not defective at a time, and they do not have any intersection. Okay, now listen to this another concept clearly. independent events. These are the events which do not impact the occurrence of others, do not impact the occurrence of others. Okay, like being defective impacts the occurrence of being not defective. Okay, having a tails impacts the event of having a head. Independent events do not impact the occurrence. Okay, there is one more concept: complementary events. Event A plus event B have the probability of 1. They are complementary. Event A equal to 1 minus B. This is the concept of complementary events. Okay. Now these things that I just discussed were the language of probability. Okay. Now let's get into the real business of counting possibilities. Basically, in how many ways a thing can happen. Okay. Let's start with MN counting rule. Okay. From your home to go to a store, there are three ways. From the store to go to the playground, there are four ways. So, possibilities of going from your home to the playground is 3 cross 4 ways. Correct? Think of it. Pause the video and think of it for some time. Suppose a scientist wants to set up a research design to study the effects of sex, male or female, marital status, single never married, divorced, married, and economic class, lower, middle, and upper, on frequency of airline ticket purchase per year. The researcher would set up a design in which 18 different samples are taken to represent all possible groups generated from these customer characteristics. Okay. So, first of all, how did it become 18 different samples? Right? Which also means how many varieties of path or how many varieties of samples can be created. Okay. Two cases, two cases, sorry, cases, three cases, right? 2 cross 3 cross 3, 18 different groups. Okay, so this is about MN rule. Okay, now there is another rule, sampling from a population with replacement. Okay, we call it n to the power n rule. Sampling from population with replacement, right? If there are 10 balls in a bag, you have to choose 4 balls, and every time you choose, you put that ball back into the same bag. Okay. Now, how many different ways will you be able to choose those balls? 4 balls. So, first, when you pick up, you will choose it 10 ways. Now, you choose that ball and then put it back again. Again, you will have 10 ways. Again, you will have 10 ways. Again, you will have 10 ways. This becomes 10 to the power 4 ways. This is one rule, n cross n to the power n rule. Okay, let's see this. Each time a die which has 6 sides is rolled, the outcomes are independent with replacement of the previous roll. Okay, if a die is rolled 3 times in succession, how many different outcomes can occur? A die is rolled 3 times. How many different combinations can occur? In first roll of the die, you can have 6 values. In second roll of the die, you can have 6 values. Third roll of the die, you can have 6 values. 6 to the power 3. Okay. Sampling. So coming to another case, which is sampling without replacement. Now I'll take a new sheet to explain this. Okay. So we are checking sampling without replacement. What does it mean? If you are picking up a ball from a bag of 10 balls, for the next pickup, you are not replacing that ball which you picked in the first time into the same bag. Okay. So how do we calculate it? For this, we use something called as combination. See, 10, 4. From a bag of 10 balls, you have to pick 4 balls. How many ways can you do it? Without replacement is represented by combination 10, 4. C 10, 4 or 10 C 4. Any which ways. This means 10 factorial divided by 4 factorial into 10 minus 4 factorial. Let me explain the concept behind this. Okay. Now, going to the previous way where we did with replacement, we did 10 cross 10 cross 10 cross 10. Now, if you want to do without replacement, if I pick 10 balls, In the first, so in the first pick, if I have 10 ways to pick a ball, in the second one, I'll have 9 ways because one I have already picked in the previous one. Similarly, in the third one will be 8, one will be 7. Okay. Now, what does factorial mean? Factorial is something like this: 3 factorial is equal to 3 into 2 into 1. A way of representing the multiplicative terms in a decreasing order. 4 factorial is equal to 4 cross 3 cross 2 cross 1. Okay. And so on. So 100 factorial will be 100 cross 99 cross 98 and so on. Right. Now we have to find a way to show this, that sampling without replacement, these many ways I'll have. So that can also be represented as 10 factorial divided by 6 factorial. Right? 10 factorial divided by 6 factorial, which is giving this. Now, what is this extra 4 factorial doing? Okay. The extra 4 factorial is saying, now that you have 4 balls chosen, how many ways can they be arranged? They can be arranged in 4 factorial ways, right? Similarly, like you selected 10, 9, 8, 7, from 4 you can select it 4, 3, 2, 1 ways, which makes it 10 factorial by 6 factorial into 4 factorial. Nothing but this. Okay. Combination means C n n is equal to n factorial by n factorial big N minus small n factorial. I hope you got the concept why sampling without replacement is given by combination. Okay, let's see if I have a problem. Yes, number of ways you can choose 4 balls from 10. Sorry, this is without a replacement. Okay, now watch till the end so that you can also answer the assignments in this video itself. Right, now let's discuss about union. Okay, the formula of union P of x union y is given by probability of x plus probability of y minus probability of x intersection y. Okay, why do you subtract this? To avoid double counting. This is x, this is y. If you add x and y, this area is counted twice. So you subtract 1 to keep this area whole. Okay. Let's see law of addition. Some partners conducted a survey for American Society of Interior Designers in which workers were asked which changes in office would increase productivity. Respondents were allowed to answer more than one type of design change. The number one change that 70% of the workers said would increase productivity was reducing noise. The second was storage filling space was selected by 67%. If one of the survey respondent was randomly selected and asked what office design changes would increase worker productivity, which is what is the probability that the person would select reducing noise or more storage filling space? Okay, focus word or. Or means union, and means intersection. Okay, I hope you know the reason why. Still, if you have doubts, you can ask me. So, in this example, we have 0.70 for one suggestion, 0.67 for other suggestion. Okay, now if there is no intersection, we will assume that it is 0. Correct? Now, what does it make? It makes the probability to be 1.37. Okay, now food for thought, is it correct or not? This is also part of your assignment. You have to tell me if this answer is correct or wrong. Okay, now this is law of addition. Now, there is something called as law of multiplication. P of x intersection y is equal to P of x, probability of x, into probability of y when x has happened. This is how we represent it. Or is equal to probability of y into probability of x when y has happened. Okay, don't worry. Let's understand this part with an example. According to US Bureau of Labor Statistics, 46% of the US labor force is female. In addition, 25% of women in the labor force work part-time. 25% of women in the labor force work part-time. Okay. What is the probability that randomly selected member of the US labor force is a woman who works part-time? Labor force is a woman and works part-time. And works part-time. Okay. P of x intersection y. Probability of women working part-time into probability. Sorry, this is P of W, which would be probability of women, workforce women being a female. sorry, probability of US labor force which is female is 46. Let's say this. Okay. Into probability of women in labor force who work part time. Right? This can be represented as, this is the probability of women in the workforce, probability of people working part time given that those people are women, which is equal to 0.25. Okay, that is what this symbol means. Occurring of T when W has occurred. Okay, just understand the basics, the logic of it. Okay, we won't need a lot of depth in it, but then we should know so that when the higher topics come up, you can have an intuition in your mind. Now, one final concept which is conditional probability. Before we go there, so assignment for you is to complete these two questions. You can pause the video and work on these two questions before we jump into conditional probability. Okay. Now, conditional probability is the explanation of the previous concept that we said, occurrence of X when Y has occurred. X and Y. Okay. In this, what is the probability of occurrence of X when Y has occurred? Okay. So here, using the fundamental concept of probability, n e by n, the population here is Y, because we are calculating the part of X in Y. Okay. Part of X in Y can be represented as over in Y. Okay. Which can also be represented as, from the previous example, you would remember this would mean probability of X into probability of Y given X by probability of Y. In the previous slide, I guess you would understand how this became this. Now, establishing this relationship is called conditional probability. Okay, let's see the example. in the study of some partner to determine what changes in office design would improve productivity. 70% of respondents believe noise reduction would improve productivity. 67% said increased storage space would increase productivity. In addition, suppose 56% of respondents believe both noise reduction and increased storage space would increase productivity. Okay, 70% say noise reduction. 67% say increased storage. 56% both. Suppose this is A, this is B. A intersection B is 56%. Okay. A worker is selected randomly and asked for changes in office design. This worker believes that noise reduction would improve productivity. What is the probability that this worker believes increased storage space would increase productivity? Probability of storage space noise reduction has already happened. This is equal to probability of storage introduction, sorry, uh, intersection noise reduction over probability of noise reduction. This is equal to what? You calculate. Okay, simple answer, but then concept of conditional probability is being laid, right? Now that being said, let's solve the question that I gave you in the class. Okay, so this is the question. Imagine you are a financial analyst at an investment bank. Go ahead. Yes. According to your research of publicly traded companies, 60% of the companies that increased their share price by more than 5% in the last 3 years replaced their CEOs during this period. 60% whose share price increased by 5% replaced CEOs. At the same time, only 35% of the companies that did not increase their share price by more than 5%, 35% of the companies that did not increase the share price by 5% replace their CEOs. Okay. Knowing that the probability, knowing that the probability that the stock prices grow by more than 5% is 4% only. Stock prices going above 5% is 4% only. Find the probability that the shares of the company that fires its CEO will increase by more than 5%. Probability of probability that the shares of the company that fires its CEO will increase by 5%. Share increase. Right? This is the question basically. The share would increase given he is fired. I said replaced because I had written replaced here. Okay. Now, so this is a special case of conditional probability. You don't have to really know it. Okay. Or you don't have to know the formula version of it. But let's solve it logically. Okay. So what is the probability that the share increases by 5% and the company fires the CEO? The share increases by 5%, 0.04, and the company, this has happened, will fire the CEO, which is 0.6%, right? Now, this is divided by, because this is conditional, it will be divided by the total case where we will see how does the market deviate with 5% share price. Okay, why I am saying so? Because whatever be the market, we are trying to find out if the CEO is fired, what is the probability of increase in 5%. Okay, so for that we have to consider the whole market as our sample space. When I say that, what do I mean? First case being 60% into 0.04, which is if the share price increased 5%, what probability would be replacing the CEOs, plus if it is not increasing by 5%, what percent would replace the CEOs? This basically I solved it using NE by N concept. Okay, but anyways, you don't have to really worry about it. So you have to understand that what conditional probability means. Probability of X intersection Y happening when Y is given. Okay, so that's it for the basic probability class. In the next video, what we'll do, we'll discuss about some more basic topics, okay, so that we understand the session 6 which I was trying to show.